Okay, so let's, as I was just mentioning some time back. So, yeah, question on what? Okay, what is the question about? Oh, okay. The question is about power factor correction. Okay, so instead of directly, maybe I think there are so many other connected questions, all that in that, right? So, anyway, I think that is something which could be discussed now. So, you can help me with your question paper code. Okay, just a minute. Okay, so I'm opening one PDF. Okay, let's go there. So, by the way, the first 20 questions are about complex numbers, not related to only electrical. It is all engineering. It is same. So it's very general. So please go through it. Okay. So here question is connecting an inductor capacitor additionally in parallel to voltage source power factor becomes one. Determine the value. So okay, maybe I will not solve exactly this problem, but something similar I will do. So, okay, let me take a simple example here. So, question I want to solve is, I think, just simply. So, I'm drawing a simple AC circuit on the screen with the parameters. See, the resistance considered as 10 ohms. So, let's speed up. So, inductance considered as 50 millihenries and capacitance considered as 100 microfarads, and supply voltage may be considered as 80 volts at an angle 0 degrees, and I will also mention the frequency. So frequency is 50 hertz. So in fact we can use the same problem to study two concepts that we are discussing, that is power factor correction and resonance. So let's first talk about power factor correction. First, let's talk about power factor itself. Okay, so what is the steps? So let's say the question is find out the current. So what is the current? That is a question. So for finding out the current, you will find out the impedance. So how do you find the impedance? So this is already in ohms, but this is in millihenries. Millihenries have to be converted to ohms. So how do you convert millihenries to ohms? So we have XL. So this is called inductive reactance. Okay, so XL is a quantity. Inductive reactance is a function of the inductance value itself and frequency. So it is J omega L. So again, you might have already studied this in various other uh, subjects. So omega is nothing but 2 into pi into f, and J is the imaginary component. So 2 into pi into 50, because frequency is 50, and L also 50 millihenries. Okay. So what is this? So 2 multiplied by pi multiplied by 50 multiplied by frequency again 50, sorry, frequency already considered, into 1 e minus 3, because milli means you have to uh, convert to 10 to the power minus 3, so you're getting 15.7. So you understood this step. So J also will be there. So that is XL. What is XC? So 1 by J omega C. This is the formula for XC. 2 pi into frequency is 50 and C is 100 micro. So the micro, I can take it to the numerator. So it becomes 10 to the power of 6. Okay. So again, let me calculate this. So 1 divided by 2 into pi into 50 into 100 into 1 e minus 6. Did I make anything wrong here? I was not expecting. Okay, let me calculate again. So 1 e6 divided by 2 pi f into c. Okay, 31.83. So j in the denominator goes to numerator, it becomes minus j. So what is the total impedance? First resistance is 10 ohms. That is a real component. And the imaginary component is 15.7 minus 31.83. So that will be 10 minus j, 31.83 minus 15.7. Sorry. So please keep an eye on whatever calculations I'm doing. If I make a mistake, please let me know. Okay. So far up till here is everything fine. So this step is pretty standard. So you should all be comfortable how to do this part. Now, how do you find the current? So current is voltage divided by impedance. So voltage is already in polar form, whereas the impedance is in rectangular form. Okay. So either you can directly use a calculator and find out the current, or you can convert this into polar form and do that. Okay. So I will, and 80 with 0 is nothing but equal to just 80 plus j0 or something like that. So let's calculate it here. So basically what I am now calculating is 10 minus j 16.13. I don't know whether this will work with Google search. So let's check. So equal to 80 divided by 10 minus, what was the value? 16.13 I. Okay, good. So it is detecting the what you call complex numbers. So I got the current. Voltage divided by impedance is current. So 2.221 plus 3.582. Okay, so let's, So I got the current value here. But what was the question? What is the power factor? Okay. So let's convert the current into polar form. Okay. So okay. So I got some. I don't want all these calculations. So let's look for. Okay, I found an online calculator where I can enter the rectangular value and we'll get the polar value. It's taking time to load. What it's not accepting. So again, you are following, right? What I'm trying to do. So I'm getting r and theta in degrees. 4.215 and 58.2. Sorry. So this is the current. Okay. So in other words, the current here is 4.215. That is the magnitude of the current. Oh, what happened? Is there a problem here? Yeah. So you got. So if I connect a ammeter here, that will measure 4.215 amperes of current. Okay. Again, up till here is everyone clear? Now the important step, I want to draw what is called as a phasor diagram. Okay. So the phasor diagram looks something like this. Okay. So I draw one horizontal line representing the voltage. The length of this voltage line is 80 volts and the angle of that line is 0 degrees. So it's a horizontal line. Now the current. Okay. So current from here, let me change the color. So 4.215 amperes and this angle is 58.2 degrees. Okay. So, so this small diagram that you see on the screen at the bottom, that is the vector diagram for this circuit because we have one voltage and one current, and that is the diagram. Okay. So, what is power factor? Power factor is the angle between the voltage and current. You take whatever is the angle and apply cos. That is called the power factor. So, power factor cos of 58.2 degrees. Okay, so again, you need to use a calculator. So here you need to be careful. Most of the time, the calculators, uh, unless you specify degrees, they're not considered degree. I think in this case, again, Google is doing good job. So 0.5269 or 0.527 is the power factor. So if you did not give the degrees, it will consider as radians and you'll get a wrong answer. So I'll just show you that. So if I remove this, so cos of 58.2 radians happens to be something, some number like that. So which is wrong. Now we'll come to the question. Okay. So the question that we are discussing in today, I'm sorry, not this one. So the question number 28. Okay. Now what I want to do is I want to make the power factor equal to 1, which means the cos of, what is cos of 0 degrees is 1. That means I need to make the angle between the voltage and current equal to 0 degrees. Okay, so like that. So how to make the angle between voltage and current equal to 0 degrees? So in this case, you look at the uh, diagram here. So here what we say is current is leading the voltage. Okay, so again this is important point. The current is leading the voltage because if I take if I stand here and look at the phasor diagram, first the current would be going because all these phasors assumed to be rotating in anti-clockwise direction. So current is leading and voltage is following the current. So therefore current is leading, which means the total circuit is of capacitive in nature. So the circuit having a capacitive nature. Okay. Now, to cancel out the capacitive nature, you need to add inductor to the circuit. If at all the circuit was inductive in nature, then to cancel out the inductance, you need to add a capacitor. Okay, so that way. Now, so here what I will do, I will maybe I will go to a new page and I will. It's too bright. Okay, so what I will do now is redraw the circuit again. This time I will add one more branch here. In this branch, I will add an inductor. So the voltage remains same as earlier, that is 80 at angle 0 degrees. This is the voltage. And the values are, this is 10 ohms. Uh, can you remind me what these values are? This was 31 point something, right? So 31.83 and 15.7. So here this inductance is unknown. Okay. Again, you are clear until here, whatever I'm doing. Now, what was the current here on this line? So let's call this current as I1 now. So that was 4.215 at angle of 58.2. What happened? I think I lost the circuit. Is it a problem with saving? Let's redraw again. This time little quickly I'll try. So this is 80 volts. So this current is I1, 4.215 I remember. So 58, is that correct? 4.215. So now if I draw the phasor diagram here, so I will get this as V and this as I1. So now is the important point that you need to understand here. So I have drawn the voltage vector and current vector. Okay. If I label the current in this branch, in the new branch, as I2, okay. So what will be the relation uh, between I2 and V? Okay. So the relation between I2 and V will be like this because it's a pure inductance. There is no resistance in that second branch. Whatever current flows in the second branch will be exactly 90 degrees angle with the voltage. Okay, 90 degrees lagging with the voltage. Okay. Now what determines, so this will be 90 degrees. So what determines the length of this length of this is the value of the inductance here. So if the value of inductance is more, then the current will be less. If the value of inductance is less, the current will be more. Okay. So what should be that length so as to make the overall current? See what is this current? Okay, so if I mark the current here, this will be I of t. Okay, so total current is the addition of, so I of t, total current is equal to I1 plus I2. Okay, so again these are not real numbers. All these are vectors or complex numbers. Okay, so this is a complex number. This is a complex number. This is a complex number. So, what is my requirement? My requirement is the IT should be something like this, along the V, and this length, whatever comes here. So, if you see the addition of two vectors, the parallelogram addition kind of thing. So, this length, so let's say OA should be same as you know B and C. So, the BC length should be equal to OA length. Only in that case, the addition of I1 and I2 so will become, so let's call this I2. So what is I2 in this case then? So the I2, I know angle is always minus 90 degrees because it's a pure inductance. What is the magnitude of I2? So you know this angle and you know this length. So this length is 4.215. This angle is 58.2. So therefore, what is this one? So 4.215 multiplied by cos of 58.2 at an angle of minus 90 degrees. Okay, so see, I'm solving the problem graphically, but you can also solve it in various other ways. Yeah. So what was the power factor? So cos is power factor, right? Can anybody remind me what was the power factor before? I think how much? 527. 4 4.215 into 0.527. So it is 2.2213. So we have seen this number before, you remember? Actually, I could have avoided all this calculation. So this is the value of I2. Okay. So if I2 is the current in the second branch, that newly added branch. So what is impedance of the second this thing Z2? Z2 will be V by I2. So that is 80 divided by 2.2213 angle of minus 90 degrees. So what will that be? So I will say 80 divided by previous answer. So 36.01. So I'll round it off to 36. So this is J 36 ohms. Okay. So this 36 ohms have to be converted back into inductance value. So how do you conduct that back into inductance value? So I will say L2. Okay. So here this is 36 ohms, J 36 ohms, which is nothing but L2 equal to 36 divided by 2 pi f. Okay, divided by omega, that basically. So it's come to 0.1145. I'll round off to, okay, 114.6 millihenries. Okay, so you have to convert to millihenries. So if if I have a 114.6 millihenries inductance as a second branch parallel to the voltage supply, that will take that will have impedance of minus J36. That will have a current of 2.213 at minus 90 degrees. That will cancel out this current, and only the final current will be the real component of this. I think I made a mistake. Sorry for the confusion. It's not cos, right? It is sine, right? See, what is this opposites? Opposite is sine, right? Why nobody stopped me? So here, instead of cos, you need to give sine. Okay? That's what I was wondering. Okay, now people watching the video will be confused. Anyway, so what is sine of 58.2? Let's correct it. So it's actually 0.84, 0.85 I will take. So let's make the corrections 0.85 here. So then this will change to 3.5822. So then here it will be 3.5822. Then here it will be what? So where did I calculate? So I mentioned before only, if I make a mistake, you should tell me, but nobody noticed. So 22.33. Oh, I lost the. I think there's a problem if I open two, it comes like this anyway. But would I have the value? So I'll just edit it here itself. So I'm adding a new branch here. Sorry, it has to be inductance. So the inductance here is 22.33. So the L will be 1 by 2 pi f. Okay, so 1 divided by 2 into pi into 50 into our answer. This E needs to be removed. Okay, in this case, it is 0.142 millihenries. Okay, I think now you got the. So if you have this, then it will make the power factor equal to 1. Anyway, it is good thing. You have to once again verify whether whatever I showed in this is correct or not. Okay. Yeah. So this also proves a point that if you keep the assignment until the last day, last deadline, this kind of things can happen. So keep sufficient time, do it slowly, and do it correctly. Okay. So I hope you're asking what value added in parallel will. Okay, you solved the actual question, right? So what is the answer you got? 301.6, sir. Okay. Okay, so I have just about five more minutes left. I will just quickly uh, revise one more thing here. See, let's take the same circuit as before. 10. So now I'm talking about resonance. So this is 50 millihenries, and this is 100 microfarads. So the same circuit has been given to you, but this time the frequency is not 50. Okay. So you notice what is the XL? 2 pi f into L with J. What is XC? So 1 by 2 pi f C. Okay. So the value of XL is proportional to frequency. The value of XC is inversely proportional to frequency. That means if frequency increases, XL increases, whereas if frequency increases, XL decreases. Okay. So at f equal to frequency is 50 hertz. Sorry. So what was the XL and XC? So this one was 15.7, right? And this was minus J 33.14 or something like that. Again, I'm just approximately remembering the values like this. Okay. Now, what happens if I double the frequency? So instead of frequency being 50, if I make frequency 100, what happens? So this inductance will increase, it will become double, and the capacitance will become half. So let me just verify that. So I'm calculating XL now. 2 into pi into frequency 50. Sorry, frequency is 100 into 50 millihenries. Okay. So I'm getting 31.415. Okay. So you notice that this has become double. Okay. Because frequency doubled, this has become doubled. So whereas XC value will become half, obviously because it is 1 by 2 pi FC. But I'm not sure whether 33 is the correct one. I'll still calculate it. So 1 is 6 divided by 2 into pi into frequency is 100 now, and 100 micro. Okay. So 15.91. Okay. So this also, sorry. So this value has become minus 33 to minus 15, whereas this value has increased from 15 to 31.4. So obviously there will be one value of f for which both will be equal. Okay. So can you say what that value of f is for which XL and XC both will be equal? So 2 pi f into L should be equal to 1 by 2 pi f into C. L is known, C is known, but F is unknown. For what value of F is both XL and XC equal to 0? 2 pi square into LC, and F is 1 by 2 pi root LC. Okay. So it's a simple calculation like this will tell you what is the, this is called the resonance frequency, FR. So shall we calculate that? This value I think should come somewhere between, yeah, so somewhere between 50 and 100, right? We are expecting. So let us do. So 1 divided by 2 into pi multiplied by square root, sorry, L is 50 milli into 100 micro. So milli into micro. What is milli into micro? Minus 9. Okay. So I hope this is the, I think I'll leave it for you to calculate. I'm not getting what value I'm expecting, but maybe that is because of the calculation here. I mean the, so So these three zeros are here, we'll cancel out the milli, and only one micro will be there, but the square root of micro will be 3. So 1000 divided by 2 pi into root 5. Okay, so let's try that. 1000 divided by 2 into pi into square root of 5. Yeah, so 71.17. Okay, so we got the correct answer here. So resonant frequency is 71.17. So if your frequency is 71.17 hertz, then Hz, then the inductance and reactance will cancel out each other, and again the current will be in phase. The power factor will become 1. So that is it. So anyway, I'll stop here. So let's see in the next class.